Hello and welcome back to Tech and EduSpark Hub, where technology meets education. In today's lesson, we'll be looking at the complex number under the Math 101. And under this topic, what do we understand by a complex number? A complex number, let me just write that on the board. So, a complex number is any number written in the form of, so we have z equals to a plus bi. So this is a way we can have a complex number. A complex number is denoted as z equals to a plus bi, where a is a real number. So this is the real part. And what do we understand by the real part? A real part is just like a positive or a negative number. So it can be -1, it can be +1, it can be 0, it can be +2, it can be +3, and so on and so forth. And we have the b, which is the imaginary part. So these imaginary parts are just what make up the complex number. And we have the I, which is the imaginary unit. So this is the component of the complex number. So this imaginary part is just like any number that you square that give you minus or negative answer. So this is what this imaginary part is telling us about. It is any number you square that give you a negative answer. So examples of complex number are, so we have the examples. So we can have 3 plus 2i. So you can see in this example, this 3 is a real number. So this a is denoting this 3. So this 3 is a real part, which is a positive integer or a negative integer. And we have another example. We can have -5 plus 7i. So this is another example of a complex number. You can see we still have the real part and the imaginary part and the imaginary unit. So this is the imaginary part, this 7 is the imaginary part. And I said imaginary parts are the number that you square that will give you a negative answer. So we can also have 2i as another complex number, but in this case you can see we are not having any real part, so we can say no real part in this case. And also we can have 6 as a complex number, and when we have 6 as a complex number, you can see we are only having a real part, which is the 6, but no imaginary part or imaginary unit. So you can say no imaginary part. So these are examples of complex number. So moving on, we'll be looking at the imaginary units of a complex number. So let me just write that down. I said this I is the imaginary unit of the complex number. So let's look at what makes up the imaginary unit of the complex number. So firstly, we have the I, which is equal to the square root of -1. So just know that the I in this imaginary unit is equal to the square root of -1. So moving on, we have the I square. So if I is equal to square root of -1, definitely I square will be equal to -1. So how do we get this I square to be -1? Remember that we said I is equal to square root of -1. So if I is equal to square root of -1, definitely I square will be equal to square root of -1 square. So our I square will be given as, this square root can cancel this square, so we have -1. So when this square root cancel this square, you have -1. And that is how we get I square equals to -1. And we also have I raised to power 3, which will be given as, so how do we get this I raised to power 3? You can see that we said I square is equal to -1. So we can, from the knowledge of indices, we can just simply say I square multiplied by I will give us this I raised to power 3. And when we simplify this, we can say I square is equal to -1 multiplied by I. And in this case, our I raised to power 3 will be given as -I. Because when you multiply -1 multiplied by I, you have -I. So I raised to power 3 will be given as -I. And we can just simply find I raised to power 4 too. So in this case, we can just simply use the knowledge of indices to break this down. And we'll have I square multiplied by I square. So when we say I square multiplied by I square, we said I square has already been equal to minus 1. So we can just say minus 1 multiplied by minus 1. Because this I square is equal to minus 1. So that's how we have minus 1 multiplied by minus 1. And when we simplify this, we have our I raised to power 4 to be equal to 1. Because minus 1 times minus 1 will give you 1. So and we can have I raised to power 5. So breaking this down also, we have I raised to power 3 multiplied by I raised to power 2. So in this case, we said our I raised to power 3 is what? Minus I. So we have minus I multiplied by, what is I raised to power 2? Our I raised to power 2 is minus 1. So we have multiplied by minus 1. And this will be equal to minus I multiplied by minus 1. This minus can cancel minus. So we have I. And this is given as our sequence of the imaginary unit. So it continues and continues like that. You can find I raised to power 6, and you can find I raised to power 7, you can find I raised to power 8, and so on and so forth like that. And this will be all on the imaginary units of the complex number. Next up, we'll be moving to the real and imaginary parts of complex number. So let me write that down. So looking at the real and imaginary parts of complex number, let's say we have a complex number which is z, denoted as 4 minus 3i. So from this, we can denote that the real part is equal to 4 and the imaginary part is equal to minus 3. So from what we had earlier, we said we have the real part, which is a. So this a is denoting as 4, and we have the imaginary part, which is b. So this b is denoting as minus 3. So this is all to note about the real and imaginary parts of the complex number. So now, let's move to the addition and subtraction of complex number. So moving to the addition or subtraction of complex number, one thing to note is that you can only add or subtract real numbers. So you can wholly add or subtract real number together. And also you can wholly add or subtract imaginary parts. So this is the basic thing to note about the addition and subtraction. So let's look at some examples under this addition and subtraction of complex numbers. So the first example we have says that if z is equal to 3 plus 2i, so this is z1, and z2 is equal to 4 plus 5i. So the question says find z1 plus z2. So how do we solve this example? The first thing to do is to write this z1 in the bracket. So we can have 3 plus 2i in a bracket, followed by the addition sign, which is the plus that we are looking for. And we can write the z2 in another bracket, which is 4 plus 5i. We can have 4 plus 5i. So how do we add this together? All you just have to do is to rewrite this 3 plus 2i again. And you use this sign, which is the addition that we are looking for, to multiply everything that is in the second bracket. So plus multiplied by 4 will give you plus 4. Let me just write the basic arithmetic shortcut here. So we have plus multiplied by plus to give us plus. We also have plus multiplied by minus to give us minus, and minus multiplied by plus will give us minus, and minus multiplied by minus will give us plus. So this is the basic arithmetic shortcut. So you just have to note this. You don't have to cram. You just know that anyone that is having an alternative sign or opposite sign will give you minus. But if they are having the same sign, it will give you plus. So in this case, we said plus multiplied by plus 4 will give you plus 4. And also plus multiplied by plus 5 will give you plus 5i. So now we said only add or subtract real number and only add or subtract imaginary number. So what this is telling us about is that we can say 3 plus 2i will give us 5i. That is totally wrong, because we only have to add or subtract real numbers or add or subtract imaginary parts. So to do this, we just have to collect the like times of real number and collect the like times of imaginary parts. So in doing this, we can say 3 plus, because we are having plus 4 here, so 3 plus 4, and also we can say plus 2i plus 5i. So in this case, we can add real parts and also add imaginary parts because we have collected like times. So 3 plus 4 will give us 7. So we can say 7 plus 2i plus 5i will give us 7i. So this is our final answer to questions of this type. 7 plus 7i is correct, and this will be all about the first example. So let's look at another example still under the addition and subtraction of complex number. So moving to the second example says that if z is equal to 6 minus 3i, so this is z1, and z2 is equal to 2 plus I. So the question says find z1 minus z2. So to solve this question, we just have to write the z1 in the bracket first. So we have 6 minus 3i, close bracket. And this time we are asked to find a subtraction of z1 minus z2. So we can say minus another bracket and put our z2 in that bracket. So our z2 is giving us 2 plus I. So now that we have rewritten our expression as 6 minus 3i minus 2 plus I, we can just easily write this bracket first by saying 6 minus 3i. And in order to express this, we just have to multiply this minus sign by what is in the second bracket. And to do this, we can just say minus multiplied by plus 2. So we said minus times plus will give us minus. So minus multiplied by plus 2 will give us minus 2. So we can have our minus 2. And also minus multiplied by plus I will give us minus I. So this way, we said we can only add or subtract real numbers and only add or subtract imaginary numbers. So we can't say 6 minus 3i will give us 3i. That is not correct. So we have to collect like times by writing 6 with this real number by saying 6 minus 2 because it is minus that is in front of this real number. And we can say minus 3i, also minus I. So this way we have collect our like times and we can easily subtract. So 6 minus 2 will give us 4. And also minus 3i minus I will give us what? So it's just like saying you are owing 3 and you are also owing 1. So altogether your debt will be minus 4i. Because this is minus and this is minus. So when you add them together, it will be minus 4i. Because this is minus 3 minus I. So it's just like saying minus 3 minus 1i. So you have your minus 4i. And this is given as our final answer to question of this type. So let's move to the multiplication of complex number. So moving to the multiplication of complex number, this is just like solving our normal algebraic multiplication. But all we just have to note is that you have to note that I square is equal to minus 1. And this is just what to note about this multiplication. You just have to know all these imaginary units when dealing with multiplication of complex number. And let's look at some examples under this multiplication of complex numbers. So the first example we have says that if z is equal to 2 plus 3i, and so this will be z1, and z2 is equal to 4 plus I. So the question asks us to find z1 dot z2. So this dot is the same thing as multiplication. It's just a short form of multiplication. It's a product. So the question is asking us to find the product of z1 and z2. And in this case, all we just have to do first is to put this z1 in the bracket. So we have 2 plus 3i. And also, we just have to put this z2 in another bracket. So we have 4 plus I. Notice that I did not put any sign or any symbol like addition or subtraction in between these brackets. Because in this case, we are asked to calculate the product of z1 and z2. So it's just like putting these two in a bracket without any addition or subtraction sign. So to multiply this is just normal like doing the algebraic multiplication. So the simplest way or the easiest way to do it without making any mistake is to look at this second bracket. So look at the first number in this second bracket, which is 4. So you can write that out. So we have 4. So after writing that out, open another bracket and put everything that is in this first bracket, which is 2 plus 3I and close the bracket. To also look at the second number, which is the imaginary part in this second bracket, which is plus I. So we have plus I. Also open another bracket and put these 2 plus 3I in the other bracket. So it will be 2 plus 3I. So in this case, we can just easily do our normal algebraic multiplication. So we have 4 multiplied by 2, which will give us 8. And we also have 4 multiplied by plus 3I, which will give us plus 12I. And also we have plus I multiplied by 2, which will give us plus 2I, followed by plus I multiplied by plus 3I, which will give us plus 3I square. Because we are only having I in this case, so it will be I square. So now that we have done this, we can easily just simplify this. So you can say 8 plus. So remember we said imaginary parts can subtract or add imaginary parts. So we can add these 2 imaginary parts, which is plus 12I plus 2I. So adding this plus 12I plus 2I, we get plus 14I. And we can have plus 3I square. So remember that we said I square is equal to minus 1. So we can say 8 plus 14I plus 3 open bracket. What is I square? We said I square is equal to minus 1. So we can have our minus 1 here. So advancing, we have 8 plus 14I plus, so 3 multiplied by minus 1 will give us minus 3. You can see I put it in this bracket, so it will not affect this plus sign that is here. So that is why I put this minus 3 in this bracket. So we have 8 plus 14I. So plus multiplied by minus will give us what? We said anything having an alternate sign will give us minus. So we have plus multiplied by minus 3 to be equal to minus 3. So in this case, we can still collect the like times because imaginary we only add to imaginary and real we add to real. So 8 minus 3, we can just bring this 8 minus 3 plus 14I. So in this case, 8 minus 3 will give us 5. We can have 5 plus 14I. And this will be given as our final answer to question of this type. So let's look at another example still on the multiplication of complex number. Moving to the second example says if z, so if z1 is equal to 2 plus I and z2 is equal to 3 minus I. So the question is asking us to find z1 multiplied by z2. So you can easily write z1 dot z2 or z1 multiplied by z2. So in solving this question, all we just have to do is to put z1 in the bracket, which is 2 plus I, and also put z2 in the bracket, which is 3 minus I. So to solve this question, we just have to look at this second bracket, which is 3 minus I. So we can bring the first number in the second bracket out. Please always be mindful of the sign. This one is not carrying any sign, and it means there is a positive sign here. So we can have 3, open bracket. So bring what is in this first bracket, which is 2 plus I, close the bracket, and also look at this second bracket again. Bring the second imaginary part or the second part that is in this bracket, which is minus I. You can see we put the minus here because it is carrying a sign, but this is carrying a positive sign, and that's why we don't put any sign here. So we have minus I, open bracket, bring what is in the first bracket in this bracket again. We have 2 plus I. So solving further, we can multiply this by saying 3 multiplied by 2 to give us 6 plus 3 multiplied by plus I will give us 3I. So be mindful of this sign. We have minus multiplied by plus here. So we have minus I multiplied by plus 2. So we said minus multiplied by plus will give us minus because they are alternating signs. So anything alternating sign will give you minus. So minus I multiplied by plus 2 will give you minus 2I. And also minus I multiplied by plus I will give us minus I square. So moving further, we have our 6. So we can just easily deal with this imaginary part by saying plus 3I minus 2I. So plus 3I minus 2I will give you plus 1I. Or we can just say plus I. Because you are owing 2 and you are having 3 with you. So if you are paying this 2, you have 1 left with you. So that is why we are having plus I. And also we have minus I square. So we can solve for that by saying 6 plus I. Remember that we said this I square is equal to what? This I square is equal to minus 1. So in this case, we can just easily write the first sign, which is the minus that is here. And what is our I square? Our I square is equal to minus 1. And please be mindful of this sign. You can see I wrote the first sign that is here, which is minus, before I write the minus 1, which is the I square. So in this case, we can just say 6 plus I. So minus times minus will give you plus. Because we said the same sign multiplying each other will give us plus. So minus times minus will give us plus. So we have plus 1. So we can say 6 plus 1 plus I. So in this case, 6 plus 1 will give us 7. And we have plus I. And this will be given as our final answer to question of this type. So this will be all on the multiplication of the complex number. Moving to the conjugate of complex number. Remember we said if Z is equal to A plus BI. In this case, you can see we have the real part, which is A, and the BI part, which is the imaginary part and the imaginary unit. So the conjugate of Z is denoted as Z with hyphen on top. And the conjugate of Z will be given as, so we have Z to be given as A minus BI. So what the conjugate mean is just by interchanging the sign, because in this case we have Z to be equal to A plus BI. So when we want to find the conjugate of Z will be given as A minus BI. So you just have to change the sign to the opposite sign, which is minus in this case. So example of this is just that we have examples. So if you have Z to be equal to 5 plus 3I, so what do you think the conjugate of Z will be in this case? So pause this video and try and figure this out. So doing this, the conjugate of Z will just be equal to 5 minus 3I. So it's just as simple as interchanging the sign to get the conjugate. So let's look at a practical example under this conjugate of complex number. So the question we have says that if Z is equal to 4 plus 3I, find Z dot Z hyphen, which is the conjugate of the Z of the complex number. So how do you solve questions of this type? This is as simple as just finding the conjugate of Z and multiplying the conjugate of Z with Z. So how do we do this? We know that Z is equal to 4 plus 3I. So we can write that in a bracket, which is 4 plus 3I. And how can we find the conjugate of Z? We said it's just as simple as interchanging the sign in between the complex number. So we can have another bracket by putting the conjugate of Z, which is the multiplication that we are asked to find. So the conjugate of Z will be given as 4 minus 3I. So this is a way we can solve questions of this type, and we can just solve for that by doing our normal algebraic multiplication. So you can look at this second bracket and bring in the first number in the second bracket, which is 4 in this case. So we have 4. So we can put the number in this bracket, which is 4 plus 3I. So that is the number in the first bracket. And we can also pick the second number in the second bracket, which is minus 3I in this case. So multiply by the first bracket again, which is 4 plus 3I. So in this case, we can just easily expand to solve for that. So you can say 4 multiplied by 4 will give us 16. And also 4 multiplied by plus 3I will give us plus 12I. So minus 3I multiplied by plus 4 will give us minus 12I. Because minus multiplied by plus will give us what? It will give us minus. So we have minus 12I in this case. And also minus 3I multiplied by plus 3I will give us minus 9I squared. Remember we said any sign that is opposite each other multiplying each other will give us minus. And that is why we are having minus 9I squared in this case. So 3 multiplied by 3 will give us 9, and I multiplied by I will give us I squared. So solving for that, we can see we have plus 12I and minus 12I. So plus 12I can cancel minus 12I. So we have 16, because plus can cancel minus. So we have 16 minus 9I squared. So to solve this further, remember we said I squared is equal to what? Minus 1. So we have 16 minus 9, open bracket, minus 1. So in this case, we have 16 minus, so 9 multiplied by minus 1 will give us minus 9. So we have minus 9. And also we have 16 So minus multiplied by minus, any sign that is the same thing multiplying each other will give us plus. So minus multiplied by minus will give us plus. So we have plus 9, and our final answer will be given as 25. Because when you add 16 plus 9, you get 25 in this case. And this is given as our final answer to question of this type. So one thing to note is that when solving a conjugate, you can never have an imaginary unit in your conjugate. So you can see we don't have anything like I in our final answer. We are only having 25, which is a real number. So this is all to note about the conjugate. Now, let's move to the division of complex numbers. And moving to the division of complex number, let's look at a question under this aspect. So the question says if Z1 is equal to 3 plus I and Z2 is equal to 2 minus I. So the question asks us to find Z1 divided by Z2. So this is how the division of complex number works. So to find Z1 divided by Z2, all we just have to do is by writing this Z1 first, which is 3 plus I divided by 2 minus I. So to solve this question, all we just have to do is to rationalize. And in rationalizing, we just have to multiply the denominator, the conjugate of the denominator by what is on top, and also the conjugate of the denominator by what is below, which is the numerator. So in doing this, to rationalize, all we just have to do is by saying 3 plus I divided by 2 minus I. So what is the conjugate of this 2 minus I? Remember we said the conjugate is just as easy as interchanging the sign. So we can multiply this by what is on top and also multiply the conjugate by what is below. So the conjugate of 2 minus I will be given as 2 plus I divided by also multiply by what is below, which is the conjugate, which is 2 plus I. So this is a way we can solve this division of complex number. We just have to interchange this by multiplying it with the conjugate. And in doing this, we can just simply resolve it to our multiplication. So we have 3 plus I multiplied by 2 plus I divided by 2 minus I also multiplied by 2 plus I. So in solving this, we can just easily do what we did earlier in our multiplication. So look at this second bracket, bring the first number out, which is 2. You can say 2 multiplied by 3 plus I. And also, what is the second imaginary unit, which is plus I? So you can also say plus I multiplied by 3 plus I. And also divided by. So what is in the second bracket in this denominator? We have 2, open bracket. So these 2, we bring it out, multiply by the first bracket, which is 2 minus I in this denominator. And we also have plus I multiplied by what? 2 minus I. So to solve this further, we can say 2 multiplied by 3 will give us what? We have 6 plus, because we are having plus plus here. So 2 multiplied by plus I will give us 2I. And also we have plus I. So plus I multiplied by plus 3 will give us plus 3I. And also plus I multiplied by plus I will give us plus I square. So we have plus I square in this case. Divided by, so we have 2 multiplied by 2 will give us 4. Also 2 multiplied by minus I will give us what? So this is plus multiplied by minus. So 2 multiplied by minus I will give us minus 2I. And also we have plus I. So plus I multiplied by 2 will give us plus 2I. And plus I multiplied by minus I will give us plus times minus will give us minus. So we have minus I square. So to solve this further, we said imaginary we multiply or subtract imaginary, and real we multiply or subtract real. So you can just collect the like times of this numerator and denominator. So collecting the like times, we have 6. So 6 plus 2I plus 3I. So we can just add this together. If we add plus 2I plus 3I together, we have plus 5I. So you can see we have plus 2I plus 3I. It will give us plus 5I. And we can also say plus I square. So divided by, so we can also say 4. So minus 2y plus 2y. So this can cancel this. So we have minus I square. because this is what we'll be having. This minus I square is what we'll be having. If 2 plus 2I cancel minus 2I. So we will have 4 minus I square. So in this case, we can just say 6 plus 5I. So plus I square will give us what? Remember we said I square is equal to minus 1. So we have plus, open bracket, minus 1, and also divided by 4 minus, open bracket. Remember we said I square is equal to what? Minus 1. So we have minus 1. So in this case, we have 6 plus 5I. So plus times minus will give us what? We have minus 1 divided by 4. So minus times minus will give us what? Plus. So we have 4 plus 1. So collecting like times, we have 6 minus 1 plus 5I divided by 4 plus 1. So solving further, 6 minus 1 will give us what? Will give us 5. So we have 5 plus 5I divided by 4 plus 1 will give us what? Will give us 5. So we can just solve further by expanding this. So we can expand this by taking the like time, which is 5 in this case. So we can say 5, open bracket. So 5 divided by this 5 will give us 1. Plus, also 5 divided by this 5 will give us I. So we have 1I divided by 5. This 5. So this is just the same thing. If you multiply 5 multiplied by 1, you get 5. And also 5 multiplied by I will give us 5I. So we just factorize this 5 plus 5I, because when you multiply 5 by 1, you get 5. And also when you multiply 5 by I, you get 5I. So we can just simply cancel this 5 and this. So our final answer will be given as 1 plus I. So our final answer will be given as 1 plus I. So this is our final answer to question of this type. And this will be all on everything about the first part of the complex number, which is the complex number 1. Attempt this question on the screen and let me know your answer in the comments. I will let you know if you are right or wrong. And in our next lesson, we'll be moving to the second part of the complex number, which is the complex number 2, where we'll be talking about the polar form of complex number and the rest. So if this video helped you understand the complex number, don't forget to like this video, comment your answer to the question asked, and don't forget to hit the subscribe button and turn on the notification bell so you won't miss any lesson updates from Tech and EduSpark. And until next time, keep learning, keep coding, and I'll see you in the next